Okay, students, another twist on a series circuit as we build our understanding is, excuse me, we have once again our resistance boxes. We have our power coming from our battery. And now what we can do is we can now say that we want to investigate the amount of current that's flowing through the circuit. So that can be done. We checked resistance before, we checked voltage before, and now current. When it comes to current, what's really important here is that when we use our meter, we want to introduce the meter, if it's going to measure current, into the circuit itself, as opposed to voltage where we investigated from outside. The current needs to be measured within the circuit itself. So the meter will become part of the circuit itself. So let's say we want to measure the amount of current between this right side of this battery and the right side of this resistance box. Well, we can plug into the meter, and now you have a couple of choices here. You take a look at the ports. This one says 10 amps, and we can also connect and determine current from this side in milliamps. So you really have two choices. So general rule is that you first check your circuit with the 10 amp. This is an unfused port, so that you don't blow the fuses. You don't get the same precision, but that's the one to start with. And so let's do that before we try this one, because the milliamp, you plug into this port and you exceed a certain value, namely 200 milliamps, then you blow the fuses and this meter no longer becomes functional to determine small current values. Alright, so let's take a look at that. So let's say first of all we want to plug into the large 10 amp setting, always with the COM. And so we're using 30 and 50 for the ohms, and we know a battery will supply about 1 to 1.5 volts. And so given those conditions, what can we measure for the current specifically at this location? Well, the way you do that is you dial to the 10 amp setting, because that's consistent with plugging into the 10 amp port. And notice in this case we don't get any reading at all. And that could mean a couple of things. It could mean that you don't have good connection, which happens quite a bit in circuitry, or it could just mean that there's so little current flowing through you're not even getting a reading on the 10 amp setting, which is definitely the case here. So as you investigate Ohm's law, you're going to see that there's a connection between resistance and voltage and current in a very special, simple way. Alright, so that being the case, always good practice to dial off. And what we want to do is now connect to the milliamp setting. Alright, now when you do that, you don't want to dial to where it says, clear this so we can see, the 10 amp setting, but rather the 200 milliamp setting. So when we do that, we notice that we do get a reading. In this case, we notice 14.1. Now that doesn't mean, or 14.0, you can get fluctuations in that last decimal point, but close in the neighborhood of 14. That's not 14 amps. 1 amp would be deadly. This is rather milliamps. So if you wanted to convert to amps, you'd have to move the decimal 3 to the left, which would be 0.0139 amps. And when you calculate that out, you'll see that that makes sense in terms of the total resistance and the total voltage from the battery having a special relationship with the current, which is here. Now, what you're going to be investigating is, okay, so we've gone to all this trouble to determine the current at this location. A question could be asked is, well, what would the current reading be if, let's say, we wanted to connect over on the left side of the battery and the left side of this resistor? Or maybe we want to know what the current flow is between the resistance boxes. So that's something that you're going to be, one item that you're going to be investigating in the series circuit.